Hey everyone, welcome back to another crash course video from Team Ink and Metal. Today we'll be talking about different methods to map the field in FTC. One method to do this is odometry. Odometers track the position of the robot with an XY coordinate and the heading, the direction it is going at. This is usually done by encoders such as the US Digital E4T and S4T optical encoders and the RUV through bore encoder. In FTC, many decide to use dead wheels or wheels that have encoders that won't spin unless the robot is moving. Encoders separate from the motors are placed on the same axle as the odometry wheel to track the rotations. It is typically set up with two wheels in the front and one wheel perpendicular or horizontal to those wheels in the back. The average of the two wheels in the front gives the forward distance movement, and the difference between those wheels gives the rotation value. The perpendicular wheel in the back gives the lateral movement. The Intel RealSense T265 camera tracks position with an XYZ coordinate and heading. It uses SLAM technology, which stands for Simultaneous Localization and Mapping. With this, robots build maps as they go along to navigate their environment. They effectively map and navigate, avoid obstacles, and adjust to changes. Some pros of the Intel RealSense T265 include its accuracy even when going over obstacles. Its movement is not affected by obstacles. Some cons include its difficulty to use and code, and even the slightest tilt can cause flaws in its tracking. Gyroscopes track heading, and since it spins, rotation as well. They measure and maintain angular velocity and orientation. A pro is that it's a very accurate device, but a con is that it is difficult to set up and fix. The RevHub also has an inbuilt IMU that tracks heading. IMU stands for Inertial Measurement Unit. It consists of gyroscopes, which track angular velocity, and accelerometers, which track linear acceleration. A pro is that it is easy to program, however, it is not too accurate in tracking motion. Finally, distance sensors track position with an XY coordinate. They output signals, which can be laser, IR, LED, or ultrasonic wave signals, and read the changes it undergoes when it returns. A common distance sensor used in FTC is the Rev2M distance sensor. It measures distances of up to 2 meters. Distance sensors are accurate in tracking, but a small tilt can cause flaws in tracking. Thank you for watching.